Hello students, this question is taken from test series 2 EE from the subject electrical missions from the topic DC missions and it is of 2-mark question. Given a 220 volt 22 ampere supplies a load as a generator with armature resistance, that is RA is equal to 0.2 ohm, which is nothing but given supply voltage VT as 220 volts and current 22 ampere with armature resistance 0.2, load as a generator, and if the machine operated as a motor at same voltage and current but increased 10% of the flux, which is nothing but the motor also same voltage and current and the armature resistance, but only the flux that is increased of 10%, that is the motor flux is increasing of 1% of 10% of generator, that is motor flux phi m is equal to 1.15 G, which is nothing but flux of the generator. After this we'll get the value of this one, and we have to find the value of the ratio of motor speed to the generator speed. We have to find the ratio of motor speed, that is N2, to generator speed, that is N1, to find the value of ratio of motor speed to the generator speed. Let us see the diagram for generator having the armature, that is given armature resistance of 0.2 ohm, having the armature resistance 0.2 ohm and current of 22 ampere and the voltage of 220 volts. This is the diagram for the generator, and for the motor here armature resistance also same 0.2 ohm, but for motor it is coming to the current is to the direction of the armature. This is the voltage. The formula to calculate the voltage, the back EMF in the generator, that is E is equal to VT, that is voltage 220 volts plus IA RA. To find the value of the back EMF in here, that is EG is equal to VT, that is 220 plus armature resistance 0.2 into the current 22 ampere, then we'll get the value of EG. To calculate the value of back EMF in the motor, that is EB is equal to VT minus IA RA. That here the direction is to the armature, the current direction is to the armature, so it is here minus. For motor it is minus IA RA. We know the value of VT, that is 220 volts minus IA 222 into 0.2, then we'll get the value of this one. We had to find the value of speed, that is ratio of speed N2 by N1. We know the back EMF, that is EB, is directly proportional to the flux into N. The back EMF, that is EB, is directly proportional to the flux phi into N. From this relation we can calculate, we want to calculate the value of speed, then from here we can elaborate this like EB is equal to phi m N2, EG is equal to phi G by N1. From here EB by EG is equal to phi m N2 by phi G into N1. We want to calculate the value of N2 by N1. After N2 by N1 we have to find the value of N2 by N1, will get is equal to EB into phi G by EG into phi m. We know the value of EB, EG, phi G and phi m. Substitute the values of all in this formula, will get EB as 215.6 volt into phi G is 1 in the given 1 by 1.1. 224.4 into 1.1. After solving this one, we'll get the value of ratio of the motor speed to the generator speed, will get value of 0.865, which is the value of 0.0865, which is the, in this session we have studied about how to calculate the value of motor speed to the generator speed, and what is the operation for the generator for the back EMF, and motor, how to calculate the value of back EMF in the motor. Thank you.